Okay, we're going to talk about acceleration. Acceleration is another measure of something's motion. The acceleration is the change in velocity over the time taken. So let's think. The velocity is measured in meters per second. So acceleration is the change in speed, how many meters per second something changes per second. The change in velocity per second, or meters per second squared, is the units for the change for acceleration. So acceleration is the final speed minus the initial speed over t. V is final speed, u is initial speed. Now, just like velocity, acceleration is a vector. So we have to define the origin. Acceleration can be in the positive direction, or it can be in the negative. So a negative acceleration is often will be telling us the thing is actually decelerating. Deceleration is negative acceleration. Now, the other important formula for this is to think that when the acceleration is constant, the average velocity, so for constant acceleration, the average velocity is equal to the final speed plus the initial speed over 2, or half u plus v. This is important because if you remember the equation from before, s equals vt, we can slot in the average velocity and find the distance travelled as half u plus v multiplied by t. This is a displacement of something that is accelerating. Now, let's look at a couple of examples of how this works. So, a parachutist falls from rest to 49 meters per second over 5 seconds. What's the acceleration? So A equals the final speed minus the initial speed over t. So the final speed is 49. The initial speed is at rest, so the initial speed is 0. And it's over for 5 seconds. So that's pretty simple. So it's 9.8 meters per second squared. And later on you will find that this number is very important because that is the acceleration due to gravity. So now another one, a tractor, acceleration from 5 meters per second to 9 meters per second is 0.5 meters per second squared. Find the distance covered. by the tractor. So first we need to find the time that this acceleration took place over. So A equals final speed minus initial speed over t, so the acceleration was 0.5, final speed was 9, initial speed was 5, and we don't know the time. So it's going to be 4 over 0.5, which is 8 seconds. Now we can work out the distance. So we use our other formula, S equals a half, U plus V times T. So half 5 plus 9 times 8, and that will be 56 meters. I hope that helps.